Okay, so today we are going to start the new chapter, which is application of derivatives. Application of derivatives. So in the last few classes, we are discussing about different continuity and differentiation. Is my voice audible to you? Hello, can you hear my voice? Hello, anybody can reply? Is my voice
Yes,
audible?
sir.
Okay. So application of derivatives. So last classes we are discussing about how to find the derivative of different functions and all those things. Now it's applications. So actually सबसे पहले जो application the derivative dy by dx.
Yes, sir.
It is known as rate of change of y. Rate of ये आपका syllabus में नहीं है इस बार, but just for your information. Rate of change of y with respect to x. dy by dx is derivative. Dy by dx is derivative of y with respect to x. That is actually rate of change of y with respect to x. But that is not in your syllabus. जैसे एक सिंपल एग्जाम्पल, जैसे आपको इसका जो आइडिया समझ में आने के लिए सिंपल एग्जाम्पल बताता हूँ. सिलेबस में मीन्स एग्जाम के लिए नहीं है, फिर भी find the rate of change of the area of the circle rate of change of the area of the circle with respect to its radius when radius is equal to 3 centimeter. तो हमें पता है कि area of the circle is pi r square. हमें चाहिए rate of change of area with respect to radius. That means we need derivative of a with respect to r. That is what they are asking. Derivative matlab nothing but it is a rate of change. dA by dr. Rate of change of the area with respect to radius. That means area का a का derivative with respect to r, dA by dr, which is equal to pi is constant, derivative of r square is 2r. But हमें चाहिए the rate of change of area with respect to radius when r is equal to 3. So when r is equal to 3, it is pi into 2 into 3, which is 6 pi. 6 pi, it is area, so it is centimeter square per centimeter, because with respect to radius. So for 1 centimeter radius, the area will change by 6 pi, I say. So this is one meaning of the derivative, rate of change. ठीक है, तो इसके बारे में ज़्यादा हम डिस्कस नहीं करेंगे, इसको हमारा सिलेबस में नहीं है. हम वी आर गोइंग टू द नेक्स्ट इम्पोर्टेंट टॉपिक. Okay. So there are different functions like increasing function. We are going to discuss this. Increasing function decreasing function. This is what we are going to discuss, increasing function or decreasing function. So normally from the name itself, you will understand increasing function. Increasing function मतलब क्या होगा? Increase करके जाएगा, है ना? जैसे this is your x-axis, y-axis. You can see that ऐसे graph है तो you can see when x values are increasing, the function values y is also increasing. सही है ना? Another way ऐसे है तो भी this is increasing. When x values are increasing, the function values are also increasing. So these types of functions are known as increasing functions. Increasing function मतलब when x is increasing, जैसे when x1 is greater than x2, then f of x1 is greater than or equal to f of x2. When x1 x2 से ज़्यादा है तो उसी पॉइंट में फंक्शन का वैल्यू x2 से ज़्यादा होगा. That means when x is increasing, function value is also increasing. But here you can see that here there's a function increase हो रहे, increase हो रहे, increase हो रहे. Then for some time either it is constant जैसे होगा, then again increasing, but decrease नहीं हो गया, नीचे नहीं आएगा. So these type of functions, these types of functions, this is have a particular name. This is known as, this is increasing function. एंड हियर आप देखेंगे तो इधर ऐसे कोई पॉइंट नहीं, बीच में फंक्शन का वैल्यू सेम आ रहा है करके नहीं. इट इज वंस द फंक्शन स्टार्टेड, लाइक यू कैन सी दैट व्हेन x is increasing, when we are moving from the left to right, then you can see that the function value is increasing like that. So this is known as strictly increasing function. The previous case में ऐसे एक कुछ समय था फंक्शन का वैल्यू कांस्टेंट जैसे जा रहा था. So but still it was increasing only, it is not coming down. So that is known as increasing function, and this is strictly increasing. In the same way, sorry. So here if you look at the first one, you can see that when you are moving towards right, so when x is increasing, you can see that the function values are coming down, decreasing. And here there are some points, the values are constant also. These kind of functions are known as strict decreasing functions. This is known as decreasing, इसको बोलते हैं decreasing function. And the second case we can see that when x values are increasing, function value is decreasing. And ऐसे बीच में कोई भी point नहीं, the function values are same. So this is strictly, we can say this is strictly decreasing function. But last one you can see that इधर से increase हो रहे, एक particular point में आ गया, then decrease हो रहे, then एक particular point में आ गया, then increase हो रहे, then decrease हो रहे, then increase हो रहे. So ऐसे जा रहे. So this is, these types of functions, it is neither increasing nor decreasing. So this is the sorry, this is the idea of increasing function and decreasing function. And what is the relation with the derivative, that we will discuss. But सबसे पहले what is meant by increasing function, decreasing function is when x values are increasing, the function value is also increasing, then it is increasing function. When x values are increasing, the function value is decreasing, that is decreasing function. But in the last case, you can see that it is not completely increasing. It is increasing, then decreasing, then increasing, then decreasing. That type of function. They are neither increasing nor decreasing functions. Okay? Is it clear?
Yes, sir.
Abhi, now I'm going to the point how it relates with our derivative. Okay, see, now you can see, I think. So this is a graph of y is equal to x squared, correct? Can you see?
Yes.
Okay. Now, you can see that in the left side, when you approach from negative infinity to 0 up to that point, the function value is decreasing, 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 decreasing. Then after that, it is increasing. So look at the portion at the right side, the function value is decreasing. So if you draw the tangents, see they say I'm going to draw the tangent at different points just for you to understand. See the different tangents. As you're moving towards the right side, what is happening with the tangent? Or what is happening with the slope of the tangent? Or you can see that all the tangents, tangent का slope क्या है? Positive है क्या negative है क्या? These are all tangents, na?
Positive.
These are all tangents. This is a tangent, here a tangent. This one, spotlight क्यों नहीं आ रहा है? 1 second. These are all tangents. These are all tangents. So you can see that it is the tangents are means the line is moving. When we move from left to right, the line is going up. That means the slope of the tangent is positive. That means the relation is when f of x is increasing, when f function is increasing, matlab derivative f dash x is greater than 0. F dash x matlab slope of tangent. F dash x derivative का geometry की meaning हमने देखा था slope of the tangent. And so here you have seen that when the function is increasing, all the tangents are having positive slope. That means function is increasing matlab slope is positive. That means f of x is increasing matlab f dash x is greater than 0. Then function is decreasing है तो देखो क्या होगा. Left side में function decreasing था. अब tangent draw करेंगे तो you can see that हर tangent का slope negative रहते हैं. देखो the line is falling. When the function is decreasing, you can see that the line is falling. है ना? So you can say that when f of x is decreasing, function decreasing है तो slope of the tangent is negative, because here you can see that when the left side 0 ka left side mein function decreasing the. So if you see the tangents at different points there, you can see that all the tangents are with the slope, negative slope. Like when you are moving from left to right, the line is falling down. So with the negative slope, that means slope is negative. Slope matlab derivative, because derivative का geometrical meaning है slope of the tangent. So f dash x is less than 0. So that's all. That's a relation connecting derivative and increasing decreasing function. Increasing function matlab derivative greater than 0. Decreasing function matlab derivative uh, less than 0. So you can see that when it is at the point 0, you can see that it is turning there. So if you look at that particular point, you can see that the it is horizontal. So slope is equal to 0. नहीं तो constant function. Suppose a graph. I will show you a graph here. इसके साथ ही दिखाएंगे. So this one is horizontal line. So this has the equation. This is y is equal to 6. This is a graph. This is a constant function. This is f of x is equal to 6. This is known as constant function. So इसमें से कहीं भी आप किधर भी आप ग्राफ का tangent draw करो, the tangent will be the same line. Tangent will be the same line. है ना? So when f of x is constant, f of x is constant. When the function is constant, increasing भी नहीं कर रहे, decreasing भी नहीं कर रहे, constant है तो that means f dash x is equal to 0. So that's the relation connecting derivative increasing and decreasing function. Function increasing मतलब अभी आप जब theory भूल जाएंगे तो भी कोई issue नहीं. Function increasing मतलब derivative positive, function decreasing मतलब derivative negative, function constant मतलब derivative is equal to 0. Now we will come to the problems now. So what we have seen is when f derivative is positive, function is increasing, or function decreasing मतलब derivative negative, constant मतलब derivative is equal to 0. So show that f of x is equal to 3x plus 17 is strictly increasing on R. So you can see that 3x plus 7, this is a straight line. So graphically देखेंगे तो we need to prove it algebraically only. Graphically है तो आप देखो 3x plus 7, 3x plus 7, y is equal to 3x plus 7. X को वैल्यू दे दो, x को 0 दे दो, so y is equal to 7. So 3x plus 17. So x को 1 दे दो, it is like 20. So it is something like 0, 17. जैसे rough figure दिखा रहे, 0, 17, 1, 20. So it's something like 1, 20. So you can see that the graph will be, it will be like this. ग्राफ ड्रॉ करके आपको प्रूफ करने की कोई जरूरत नहीं. I'm just showing you to understand. So this is the graph. So you can see that when x is moving towards the right side, that means when x values are increasing, the function values are increasing only. So this is an increasing function. और कहीं भी बीच में ऐसे कोई भी point जगह नहीं, कुछ समय के लिए constant करके भी नहीं, continuous. It is a straight line. So when x is increasing, y is also increasing. So from the graph, it is clear that it is strictly increasing. But हर क्वेश्चन में से हम okay, this is linear, so we can draw the graph. बट कुछ कॉम्प्लिकेटेड फंक्शन आए तो हाथ से ग्राफ ड्रॉ करना मुश्किल होगा, सो वी हैव टू डू इट algebraically. So we know when the function is increasing matlab derivative is greater than 0, function decreasing matlab derivative less than 0. So here just find the derivative f dash x. F dash x is equal to it is 3x plus 17 ka derivative. 3x ka derivative of a sum is the sum of the derivatives, so it is 3 plus 0, that means equal to 3. So f dash x derivative is equal to 3 and it is always greater than 0. That means f dash x is greater than 0 for all x belongs to R. कोई भी रियल नंबर है, क्योंकि 3 f dash x is 3 ओनली, उसमें से कुछ 3x वगैरह आए तो when x is नेगेटिव है तो f dash x नेगेटिव होते थे, बट ऐसे कुछ नहीं, f dash x is equal to 3. That means f dash x is greater than 0 for all x belongs to a real number. That means उसका मतलब है that implies f of x which is 3x plus 17 is strictly increasing on R. So इधर मैंने ग्राफ में भी दिखाया आपको, ग्राफ is like this, so you can see that when x values are increasing the function values are increasing only. Similarly, show that f of x is equal to e to the power 2x is strictly increasing on R. So for that we have to find the derivative f dash x. F dash x is equal to e derivative e to the power 2x is e to the power 2x into 2x का derivative 2, that means 2 into e to the power 2x, 2 into e to the power 2x. And we know that x का value कोई भी आने दो, positive or negative or whatever it is always greater than 0, because x का value 0 आया तो e to the power 0 1, 1 into 2 2. Then x का value प्लस आए तो जैसे e to the power 2 पॉजिटिव, और e to the power minus 2 आए तो 1 by e to the power 2, still it is positive, so it is greater than 0 for all x belongs to R. e to the power 2x कभी भी नेगेटिव नहीं होगा. So this implies f of x is equal to e to the power 2x is strictly increasing on R. ठीक है, and f of x is equal to sin x. Prove that f of x is equal to sin x is strictly increasing on 0 to pi by 2, and it is strictly decreasing on pi by 2 to pi. So normally f of x is equal to sin x. Is it a increasing function or decreasing function? See this graph. So just पहले हमने किया था e to the power 2x. Let me see e to the power. Look at the graph of e to the power 2x. Can you see? Look at that, it is increasing everywhere. Actually, we don't need to draw the graph, but still I want to show you the function is increasing. Then another function देखो, जिसे हमने अभी बोला function जो sin x का ग्राफ देखो. sin x इंक्रीजिंग फंक्शन है क्या? Is it sin x is an increasing function or decreasing function?
No. Both.
एक मिनट, क्लास में है. Sin x is not, you can see that from 0 to, abhi this is not in radian measure. Let me see, is it possible to, okay, you can see that the function is increasing, then after a point then it is decreasing, then it start increasing. So these points, we know that these points are like in radian measure, if you like, these points are like 0, this point is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi, correct? And this is a graph of sin x. It is not increasing. 0 to pi by 2 function is increasing. Then pi by 2 to 3 pi by 2 function is decreasing. Then 3 pi by 2 to 5 pi by 2, the function is increasing. So it is going on like that. So look at that. F of x is equal to sin x. So we have to find f dash x. F dash x, derivative sin x is cos x. And we know that, see, अभी इसमें से cos x का भी ग्राफ दिखाएंगे. See the graph. 0 to pi by 2. So f of x is equal to sin x. हमने ये दिखाया कि f dash x फाइंड किया, f dash x is equal to cos x. So cos x is positive when x belongs to 0 to pi by 2. Look at the graph. ग्राफ में भी हमें पता चलता है कि 0 to pi by 2 है, तो देखो 0 to pi by 2 cos x is positive. You can see this is the graph area, क्योंकि cos 0 is 1, then cos pi by 2 is 0. So cos का value decrease हो रहा है, but 1 to 0 it is positive only. Cos x is equal to 0 to pi by 2. देखो 0 में cos x का value 1, pi by 2 में cos x का value 0. So cos x का value it is decreasing from 1 to 0, but it is positive. That means f dash x, cos x is positive when x belongs to 0 to pi by 2. So इसमें से हम ये बोल सकते हैं कि that implies sin x का derivative the cos x. So sin x is strictly increasing in 0 to pi by 2. पक्का ग्राफ में भी आपने देखा था 0 to pi by 2. You can see that sin x 0 to pi by 2 sin x is increasing. देखो, this is the black one is the graph of sin x. 0 to pi by 2 it is increasing. ग्राफ में भी हमें समझ में आ गया. Algebraically हमें ये पता चलता है कि f dash x is cos x, sin x का derivative cos x, and 0 to pi by 2 में cos x is positive, the function is increasing. Now pi by 2 to pi बोला, जैसे pi by 2 to pi देखो, pi by 2 to when x belongs to pi by 2 to pi. So here pi by 2 में cos का वैल्यू 0 हो गया, then ऐसे जाके pi में cos का वैल्यू -1. So you can see that pi by 2 to pi, that much area में, not only that much area, up to 3 pi by 2. Pi by 2 to pi, not only up to pi, actually up to 3 pi by 2, you can see that cos is negative. So here we need to prove only up to pi by 2 to 2 pi. So you can see that when x is from pi by 2 to pi, pi by 2 में cos pi by 2 0, cos pi is -1. So here in this particular area, cos x is equal to negative in that particular area. That means that cos x is sin x का derivative. That means sin x is strictly decreasing in pi by 2 to pi. So दोनों तरीके से दिखाया, ग्राफिकली भी बताया, ऑल्जेब्रिकली भी दिखाया. ग्राफिकली दिखाएंगे तो बहुत इसी ग्राफ में देखे 0 to pi by 2 sin x is increasing, then pi by 2 to 3 pi by 2 sin x is decreasing, then 3 pi by 2 to 5 pi by 2 it is increasing, then ऐसे जाएगा. पर हमने हमारा डेफिनेशन भी यूज किया, whenever derivative is positive the function is increasing, whenever derivative is less than 0 the function is decreasing.